So we're looking at page 515 in the Absolute Value Math 20 workbook. And today's lesson is on solving linear inequalities in two variables. And just before we get going on the two variables, I think it's prudent to just take a little bit of time to review solving linear inequalities in one variable. So an example I'm sure that I used with you guys previously is, for example, a speed limit on a highway is 100 kilometers per hour and the car is breaking the speed limit. That means the car speed, S perhaps we're using as a variable, is going to be S is greater than 100. So again, remembering that if we're talking about inequalities, we're using one of the four symbols. So we've got less than is our first one, of course, and then less than or equal to, greater than, and greater than or equal to, and simply not equal to. So if that's unclear, that's an equal sign with a slash through it, not equal to. So when we talk about linear inequalities in a single variable, it should be fairly obvious because here we have something that is linear, so perhaps it's in the form of y equals mx plus b, perhaps, so the degree is 1, and there is just a single variable, so we could have x or we could have a in the second example. So let's take a look then. So if we are looking for our solution, we're looking at what are all of the possible values of the variable that can be substituted in to the inequality statement to make it true. So going back to our speeding example, so if somebody is breaking the speed limit, there's any number of speeds that would satisfy that variable s. So different, an inequality different than an equation, because an equation has one possible solution. Our inequality is going to have multiple possible solutions that will satisfy it. So assuming that the variables are defined within the set of real numbers, so if we consider this inequality and if we want to solve it algebraically. So solving an inequality algebraically is very much just the same as solving an equation. It's the whole idea, whatever you do to one side, you do to the other side. You are working towards isolating your variable. The difference, a handful of differences. One, obviously not an equal sign, the inequality symbol instead. Second difference would be that when you get to your solution, it's not that single value. It represents a range of values, and therefore it can be represented on a number line. And the biggest piece that we have to remember is that when you multiply or divide by a negative, you must flip the inequality symbol. Okay, so I'll just write that out again because it is such an important piece. So when multiplying or dividing both sides by a negative, the inequality symbol must flip. So if it was less than, it's now greater than. If it was greater than or equal to, it's now less than or equal to. And so just a quick reminder on why that is, because a lot of people just memorize this and without fully understanding. So if we were to say, for example, let's say 4 is less than 6. Well, of course it is. If I just simply, let's say, add 2 to both sides, then I would have 6 and 8, and the statement is still true. So the left side is still less than the right side. If I go ahead and I multiply both sides by 3, then my new statement would be 18 is less than 24. also still true. And so if I now subtract, let's say, 6 from both sides, now I've got 12 is less than 18, still true. But what happens when I multiply both sides by negative 2? So when we multiply both sides by negative 2, the left side is now negative 24. The right side is now negative 36. So negative 24 is not less than negative 36. It is greater than. And so you just have to remember that when we go from the positive into the negative, the rules kind of change. Like, so when we're in the positive side of our number line, the larger the number, the larger the value. Whereas when we're into the negative side of our number line, if we look exclusive of that negative, if I'm just looking at 36 and 24, negative 36 is now less than 24. The bigger the number when it's negative is actually a smaller value. And so that's why when you multiply by a negative, the rules change. So a positive becomes negative, a negative becomes positive, and therefore what was greater is now smaller. Okay, and so the same thing goes, of course, if we decide to divide both sides, let's say, by negative 6, then I'm now back to the positives, where 4 is compared to positive 6, and 6 is now greater than 4. So every time I multiply, so it's the value that you're introducing to both sides. So if you're introducing an operation, and it happens to be that you are multiplying or dividing both sides by a negative, yes, you will need to flip that symbol. Okay, so let's take a look at this particular case right here. So we've got 4 minus, I'll just rewrite it again, so 4 minus 2 times 3 plus x is greater than, not greater than or equal to, just greater than 12. So I will start by perhaps subtracting 4 from the left side and from the right side. Now I've got negative 2 times 3 plus x is greater than 8, and we've got two choices at this point. You could decide to distribute in the negative 2 first, or since both sides are divisible by negative 2, I can go ahead and divide both sides by negative 2. So if I divide by negative 2, then I've just got 3 plus x, and I guess I no longer need that parentheses right there, so I'll just erase that. So 3 plus x, and so since I'm dividing by negative 2, I need to flip that symbol to less than, and 8 divided by negative 2 is then negative 4. Okay, so we can go with that way, or alternatively, if you wanted to distribute in, I can multiply in that negative 2, so I would have negative 6 minus 2x greater than 8. And so sometimes people say, well, hey, wait a second, you multiplied negative 2, why didn't you flip the symbol? Well, because it wasn't something that I introduced to both sides. This was already part of the set of operations on that left side, which was to multiply in the negative 2. It wasn't something that I was doing to both sides. Okay, so since I've got that written, we can continue with it this way, or if you had our previous answer, that's fine, continue with that as well. So then I'm going to add 6 to both sides. Now I've got negative 2x is greater than 14, and now when I divide both sides by negative 2, and then x is then less than negative 7. So again, this is me introducing the divide by negative 2 on both sides. So x less than negative 7. So when we check the solution, that's another difference between checking with equations and inequalities. For equations, we just have the one check to do. With an inequality, we could conceivably do 2 checks. So we could do a boundary check, and the boundary check is checking to see that in fact negative 7 is what we're actually looking at the values having to be less than. So the boundary check is almost like a left side, right side check for an equation. So I'm going to substitute in the, so x is equal to -7, and so my left side would be then 4 minus 2, times 3 plus x, so 3 minus 7, and just a simple order of operations question, so 4 minus 2 times -4, which is then just 4 plus 8, which is 12, and the right side is also equal to 12. So that confirms that my boundary is -7. So what do I mean again, if you're still not sure what I mean by the boundary? We're referring to if we're choosing our to graph our solution, then we are looking at, here is 0 right here, and we'll go with 1, +2, -1, -2, 3, 4. So we are looking at graphing it, so it's an open circle because it's up to but not including that value of -7, and so that tells me that boundary point is on -7. And so why is that important? Well, if we mistakenly thought that 14 divided by 2 was 8, or -8 I should say, then any value that we choose that's less than -8 is going to work. The issue is that we've missed all of those values that are between -7 and -8. Okay, and so the test case is actually looking at the direction. So test case, that's actually what it's looking for. So the test case is, well, what value could x be? And so anything less than -7, totally up to you. You could pick -8, you could pick -7.1. Obviously, because we're trying to do some mental math here, then picking in a whole value, an integer value, is probably the best scenario. I would strongly recommend, if it says less than or equal to, don't pick the actual boundary itself, because that doesn't confirm your direction. So let's say, for example, then if x anything less than -7, so I'll pick -8 then, and so then we just want to substitute that into our original inequality, which was 4 minus 2 times 3 plus -8. Is that greater than 12? And so then again on the left side now, I'm just looking at order of operations. So 4 minus 2 times -5, is that greater than 12? And that's 4 plus 10 greater than 12, and that is 14 greater than 12, and that is true, and therefore the inequality of x less than -7 is in fact the correct solution. So we've got our, here, let's just change the color. So our boundary point again is on -7. It's up to but not including, which is why it's an open circle. And it is anything less than -7, so that means that it is off to the left side then. And that's what our solution looks like on a number line. Okay, if it is less than or equal to, so then we would use a closed circle, meaning that I would color in the dot then. Okay, so let's take a look then. Linear inequalities in 2 variables. So you can see right here, again, we've got degree 1 in both cases of these examples right here. So degree 1 telling us that is in fact linear, and it is in 2 variables because, well, there's 2 variables. We've got either x or y, or p or q. So the thing to recognize in this particular case when we've got 2 variables is that we are representing our solution on a coordinate plane. So that means that we're looking at all 4 quadrants within our Cartesian plane, and we're going to use a boundary line and shade one side of the line. So The boundary line is essentially going to be a solid line, meaning that it includes all values on the line if we're looking at greater than or equal to or less than or equal to, and it is a broken or dotted boundary line if we're just looking at greater than or less than, meaning that is our boundary, so all of those points along those lines are not included. Okay, and then you're going to shade one side of the line depending on what the actual inequality says. So without using technology, okay, so the easiest way to do this is to graph the corresponding linear equation. You could use a table of values, you could use intercepts or point and slope, meaning rearranging it into y equals mx plus b format, okay, and then draw the line either solid or broken depending on if it's or equal to, so does it include that, okay? So the line then divides our Cartesian plane, our coordinate plane, into two regions. So they call them half planes. And so one side, one half, will satisfy the inequality and the other side will not. And how do we know which side? Is we're going to pick a test point, and it could be anywhere within that half plane. Obviously, the ideal is to not pick anything that is actually on the line itself. My strong suggestion would be to actually pick two test points, one on either side, and then that helps you to confirm whether or not you've got the right side shaded as well. It could potentially check if you in fact have graphed your line correctly or incorrectly. So if I'm looking at graphing y greater than x, so you're thinking to yourself, so I'll just write think, the graph itself would be y equals x. So of course in the form y equals mx plus b, then slope is 1 and our y-intercept is 0. So it is a lovely line that looks something like, here we go, like that. So that is y equals x. The problem here though is the fact that this says y is greater than x. So y does not, it's not greater than or equal, so it should not be a solid line. We should be actually using a dotted line. So let's delete that, and instead we're going to, ideally you've got a ruler as well to help you to show this dotted line. That is still a straight line that is essentially going through, following the same path as the y equals x line would, except it is a dotted line. So this shows that it's going to be a dotted line. Okay, so then we need to shade. Well, let's find a point above and below and see which one is true. And it is totally up to you what point you choose. Again, don't pick anything that's actually on the line itself of that y equals x line. Often a good place to go is actually somewhere on the axes, because then that enables you to substitute in a value for 0 for one of them. So perhaps we'll pick this point, which is going to be 0, 2, and that is above our line. And then we'll also pick perhaps this one below the line, and that is 0, negative 2. So if we take a look, our first one, if we substitute that in, we would have 2 is greater than 0, and that is true. So that tells us that that point satisfies that inequality, which means that it is part of our solution set, and we can shade in that half plane. Okay, so that should suggest then the other side does not work. So if I look at my value, that point right here, 0, -2. If I was to put that into the original inequality, so y is -2 is greater than 0, that is going to be false. So that is not part of the solution set. And you can see we could pick any value within here, any point. If I was to pick x is -5 and y is 0, well then 0 is greater than -5, also true. Okay, so we have any number of values, so the solution can only be represented on our graph. It can't be represented using our interval notation or set notation. Because everything is in relation between your x and your y. Okay, so let's take a look at class example 2b then. So 3x minus 2y less than or equal to -6. So we can do a couple things. We can rearrange it into y equals mx plus b, or we can do it using intercepts as well. So totally up to you guys. So let's say if because of the values we've got here, makes a lot of sense to use our intercepts. So if x is 0, then I've got -2y, and for my intercepts I'm going to pretend it's an equation, so -2y equals -6, in which case y is equal to 3. And so there's one point right here. If y equals 0, then we would have 3x equals to -6, in which case x is equal to -2. And so that would be 2 points on my line. And of course, with a line, you really only need 2 points in order to graph. Alternatively, again, you could also graph by rearranging as y equals mx plus b. So if I took 3x minus 2y equals -6 and I rearrange that, then add 6 to bring that onto the left side and add 2y to bring that to the right side. So we've got 3x plus 6 is equal to 2y, and then divide everything by 2. So we've got 3/2 x plus 3 equals y. And so if we look at y equals mx plus b, so b being our y-intercept, yeah, that confirms what I have there. Y-intercept is 3, and my slope is positive 3/2, so positive meaning it's going up to the right, and rise over run, so up 3, or from our y-intercept, I can start here and I can go down 3 and then over 2 to the left in order to get the slope going up and to the right. So we can continue those points. That just makes it a little bit easier for me to draw in this line then, and because it's or equal to, then that means that I can be looking at a solid line instead of a dotted line in that case. So there's that line, y equals 3/2 x plus 3, and now we want to pick 2 test points. An easy one, of course, is always going to be your origin as a test point. I'll use a different color for that. And then we can pick another point right here. Maybe we'll pick 0, 5. So if we test 0, 0, then we would see that we've got 3 times 0 minus 2 times 0 is less than or equal to -6, and that is 0 less than or equal to -6. It is less than -6, or sorry, that is not less than or -6, so that is false. So hopefully the other one is going to work then. So if we test 0, 5, then we've got 3 times 0 minus 2 times 5 is less than or equal to -6, and that would be -10 less than or equal to -6. It is less than -6, so once again we have that top plane as our shaded region. So any particular point above or on this line will satisfy that equation. So there are literally infinite possible points that could be substituted in to make that particular inequality true. Okay, so once again, your goal is for these inequalities is to graph your line. So pretend it's just an equal to. Graph the line, but pay attention. Is it a dotted line or a solid line? And then pick test points, substitute them in, and see which one works. If they both work, and I've seen people manage that before, usually what that means is one of two things. One, either you've substituted in the values incorrectly, or it is possible that you have graphed your line incorrectly. And that's usually what's happening right there. So graph the following inequality without using a graphing calculator. So class example number 3. So y less than 3/4 x plus 3. So we want to graph y equals 3/4 x plus 3. But since it's less than, not less than or equal to, it's going to be a dotted line. So I know my y-intercept is 3 and my slope is positive 3/4, so rise 3 and over 4, so that's going to be another point there. Rise 3 will be 6 and over 4, so somewhere around here, and we're looking at a dotted line through here. And so this is the actual line y equals 3/4 x plus 3, that is not included as part of our solution. And let's pick 2 test points. So again, the origin is a great place to start since the line doesn't pass through the origin. And once again, actually maybe we'll pick that point right there, -5, 0. So we'll test 0, 0 first. So 0 is less than 3/4 times 0 plus 3. So 0 is less than 3. That is in fact true. So that implies that this, since 0, 0, the origin is part of the solution, then we're looking at this whole half plane. If we test the other point that I had indicated, -5, 0, then hopefully that should not work. That won't be true then. So we've got 0 less than 3/4 of -5 plus 3. So 0 less than, I guess I could have picked a multiple of 3, that would, or a multiple of 4, that would have helped a little bit. So -15 plus 12/4, which is of course the same as plus 3, and so then we're looking at -3/4 here. Whoops. And 0 is less than -3/4. That is of course false. So that confirms the fact that we have the right side shaded, the correct side shaded, I should say. Okay. So the little note that it says here, if the boundary line is given in the form y equals mx plus b, then the region above the line is y greater than mx plus b. The region below the line is y less than mx plus b. And then the simplest point to test is always going to be the origin, of course. So this piece here, certainly, yeah, you could go ahead and memorize it. My concern is that if it's maybe rearranged in a slightly different way, then people get themselves confused as to which side to shade. So my thought is always just pick a test point. It's pretty simple to pick a value, just to substitute in, just to check. It literally takes you less than a minute to do that. Okay, so this is an interesting one. They've actually given us the shading, and they've asked us to determine the actual inequality. So the boundary line has intercepts of -2, 0, that's this guy, and 0, 4. So determine the equation of the boundary line. So a couple of things that we know. Well, so since we know our 2 intercepts, we could find our slope because we've got our we could do the slope using slope formula, or we could actually just go ahead and count as well. So slope is rise over run, and so we've got a rise of 4 and a run of 2. So slope is 4 over 2. We can see it's rising to the right, so it's a positive slope. So our slope is just going to be 4 over 2, also known as 2. And our y-intercept is 4. So b is equal to, whoops. So b is equal to 4. So the equation for this line then is y equals 2x plus 4 then. So that's pretty straightforward. If you didn't have the ability to count, if they've just given you points, then certainly you could use the slope formula as well, or you can use point slope form. Okay, so determining the inequality, then it's one of those things too. Again, we could go back up to what this little cop says right here, recognizing that it's the region below the line, so y is less than 2x plus 4. But again, if you're not sure and you don't want to just guess, you could just pick a boundary point and say, is this going to be true? So in this case, if we pick 0, 0, and if we substitute that in, so if I've got, then 0 is, and we've got some symbol here we're going to insert, so 2 times 0 plus 4. So really we've got 0 and 4. Because this point is going to be true, it's part of the solution, so I need the statement to be true. So 0 is less than 4, so that means then y is less than 2x plus 4. And but hold on, because that was a solid line, it is y is, whoops, less than or equal to 2x plus 4, and that is our inequality. Okay, awesome. Please let me know if you guys have any particular questions. Thank you. Thank you.